Hello everyone. So I'm back with the topic. Just note it. We're gonna do the following topics, that is standard points, standard moments and applications in this and the consecutive videos. Numericals will be easy for us if we are thorough with the basics. So not wasting a second, let's start our basics. We're gonna learn the standard points in this video. So moving to the first point, the first point says that at intermediate support there will be bending moment. That is, this is a beam ABC. Here B would be having the bending moment as unknown, that is we can find the value by TMT method, and here A and C would be having the bending moment as 0. Since there is no prior or there is no after supports in this beam, therefore A and C bending moment would be 0. But dissimilar to this, the bending moment for B would be something unknown to us. Moving to the next point, in TMT there should be 3 supports. That is, here it is a beam and also A, B, C supports are given. But do you think that in this really the TMT can be applied? The answer is no. Since BC part is a overhanging part, so it is not a support, it is the overhanging part of the beam, and hence there are only 2 supports, that is A support and B support, so no TMT would be applied. But in the next case, here since it is a fixed support but it is a support and the 2 supports, therefore hence here the TMT can be applied since 3 supports are found. Moving to the third point, here the supports are given, that is this is the fixed support and these are the simple supports. Now in case of fixed supports, here an imaginary span, that is A0 span would be created, and the method for which we can be write the TMT would be A0 AB, ABC and BCD. Here we would be applying TMT for 3 times. Since here the supports are A, B, C, D. So here the TMT would be A0 AB, ABC and BCD. Moving to the next point. Here the beam ABCD is given. As earlier discussed in the second point, this is the overhanging part and there would be no support here. So this is not considered for the TMT portion. Now this would be solved as this is a fixed support, we would be taking it as the imaginary span elongated prior to the fixed support. So this is A0 whose L0 would be 0, whose A0 would be 0 and X0 would be also 0. So here it would be, as since it is a uniformly distributed load, so 20 into 2 into 2 by 2, that is 1. So 20 into 2, 40. Now the value of MCD would be the value that of 20 into 2 into 1, that is 40. Since it is going anti-clockwise, opposite to the clockwise direction, hence it would be negative. So here the MCD value would be minus 40. Moving to the next, last and the most important point, here the beam is ABC. Now this is a complicated support or complicated moment given on the beam. So how can it be solved? Let's see that. Now here first we need to simplify it. Now this is a beam. Now here 2 supports would be acting, that is RA and RB. Why RA and not RC? Because the moment or the force is acting between A and B. Therefore we would be taking it as A and B, that is RA, reaction RA and RB. Now simplifying it, 100 in the downwards direction. This is a moment, therefore 100 into 0.2, that would be 20 and 2 meter, and 2 meter is already given, so 2 meter and 2 meter. Now it is important to solve it after the simplification. Now it would be, as it is going upward direction, it would be considered as positive. In downward direction, it would be considered as negative or vice versa. So now RA plus RB will be equal to 100. This would be our point number 1. Now this was the reaction diagram or the reaction forces summation. Now let's take the summation of the moment along the A point or A reaction. So it would be 100, the force that is coming downwards, 100 into 2, that is force into distance. The force coming downwards into distance. So the force is 100 into 2. Now why it is positive? Since it is going clockwise, that is we need to see it through the angle of A, that is it would be moving as clockwise. If we are standing at this point 100, that is point load, and if we need to go to A point, so it is going as clockwise, so of course it would be positive. So 100 into 2. Now plus 20, because it is already given 100 into 0.2, so it would be plus 20 again in the clockwise direction, therefore positive. Now RB, we are standing at RB for example, and we need to go to point A. So here we need to consider this whole span, that is 4 meter, 2 meter plus 2 meter, 2 meter plus 2 meter. So now here we need to take the path of from RB, that is from point B to point A. Therefore from RB to RA or from point B to A, it is anti-clockwise, that is opposite to clockwise direction, therefore it would be considered as negative. So by solving this equation, we would be getting RB equals to 55. I will repeat. By solving the summation of moment, we will be getting RB as 55 kilonewton. Now putting this RB value in equation 1, that was the summation of reactions RA plus RB minus 100. Again revising, upward is positive, downward is negative. We would be getting it as 45. That is RB is 55, RA will be 45. Now drawing the same or the reaction diagram or the action diagram for the same, that is only for the part A and B. After resolving it or simplifying it, the diagram would be, this would be a line, and here it would be RA, since RA is 2 meter far from the point of loading, so it would be 45 into 2, and here the RB is from 2 meter far from the point load, so it would be 55 into 2. So the obtained or the resultant action diagram would be this. So that's all the standard points for TMT. In upcoming video, I am also gonna solve the tricks of solving TMT so that it would be fun solving for all of us. Thank you so much for your support. My all well wishers and their suggestions are always welcome. So buckle up for the next video, that is of standard moments. Do like, share and subscribe to my video. Thank you all. Happy learning.